Hello and welcome to this video on graphs. Now graphs are very important data structures. We will start with a bit of theory, that is only this video, where we will introduce some graphs and the jargon associated with the graphs, and next video onwards we will start writing code. Okay. So graph theory is actually a subject which is typically taught in two different departments. One in computer science courses and another is in mathematics. Essentially, it is a mathematical subject which requires proving the theorems and all, but it has great uses in programming also. Since this is a data structure course, we will limit ourselves to only simple problems, and we will implement basic techniques using graphs. So some of the interesting problems which you can solve using graphs are listed below. For example, suppose you consider the world, and you want to travel around the world to different cities of different countries, and you want to plan your route using airlines. Then how would you plan it? That's a problem which can be solved using graphs. Now suppose there are n number of jobs and n number of people are there, or you can take mn if nn is not suitable to you. Suppose there are m people and n jobs where each person can do different number of jobs. So how do you allocate them for maximum total utility? Now another problem, the third one, which could be is that suppose in your country you have to lay down network cables or telephone lines or electricity lines, or even you want to do roads, that is you want to lay down roads. How will you do it in such a way that it costs minimum? Okay. The other problem is a very famous graph coloring problem, which is about coloring a graph in such a way, or map rather, in such a way that neighboring regions receive different colors. Then there is a famous traveling salesman problem, which visits different cities. So how would you minimize the travel time? So there are many more applications of graphs like this, and there are very interesting problems which come into picture using graphs. That's why it's an entirely dedicated subject. There are lots of books written on graph theory which you can read. But for the data structure course, we don't need to really need a book. We will just solve simple problems. So these are some graphs. Now the first graph contains A, B, C, D, E, F, G, H. So these two disjoint graphs are together actually. Similarly, if you see graph B, the graph is same. The only difference is that there are arrows in this. Graph C is there. It is of a form of tree. And graph D is basically where we have parallel lines. So we'll come to know about these, the jargon of this. So essentially a graph consists of nodes or vertices. So A, B, C, D, E, F, these are nodes or vertices. Set of vertices is called vertex set and is typically denoted by V of G, where G represents the graph. Vertices are denoted by V1, V2, and so on up to Vn. Nodes or vertices are connected by arcs or edges. So these straight lines and the arrows and the loop, these are arcs or edges. The set of edges or arcs is called edge set and is typically denoted by E of G, where the set contains E1, E2, E3 up to En. So if you look at diagram A, then you will quickly Observe that V of G is A, B, C, D, E, F, G, H, and the edge set is A to B, A to C, A to D, C, D, C, F, E, G, and AA. Now AA is the loop on itself. We will come to the loop in the next slide. When the node pairs or vertex pairs of which edges constitute are ordered pairs, the graph is said to be a directed graph or digraph. The graph shown BCDR digraph. Essentially, it means that in the pictorial representation, there will be an arrow. Now, the head of each arrow represents the second vertex of the ordered pair of vertices making up an edge, and the tail of each arrow represents the first vertex of the ordered pair. So, in this case, B would be the second node, and A would be the first node or first vertex. B would be second vertex, and A would be first. Between A and D, D is the second vertex, and A is the first vertex. Between C and F, C is the second vertex, and F is the first. Now, the edge set of the graph B is also given here, which you can read. If you look at diagram C, then you observe that when you will try to draw a tree, for example, a binary search tree, then it will always be a graph. But the reverse is not true. The graph is not always a tree. For example, you can look at A, B, and D. These are not trees. But a tree, for example, in C is always graph. And also, it is not necessary for a node to be connected to the graph. For example, if you look at H, it is on its own. It is not connected to any other vertex. A vertex V is incident to an edge E if V is one of the two vertices in the ordered pair of vertices that constitute E. This is typically written as U left right arrow V. It means U is adjacent to V. Okay. Here U is called successor of V and V is called predecessor of U. Now the loop which is on the node A in graph A and B is called a loop where the endpoints of the edge are equal. This would be in the angular bracket, we show it as A comma A. Parallel edges or multiple edges are edges that have same pair of endpoints. For example, it is shown in D. If n edges are incident on a vertex, then that vertex has a degree of n. For example, H will have a degree of 0. C will have a degree of 3. A will have a degree of 3. D will have 2. F will have 1, and similarly. So that is called the degree. Now, if a vertex has n incoming edges, this should be edges, then that is called in degree of the vertex, and number of outgoing edges are called out degree. For example, in graph A, outgoing is 1, and 2, and 3. So that is the out degree. We won't count this loop here. For example, C, incoming are 2, one from A and one from F, and outgoing is 1 towards D. A relation R on a set A is a set of ordered pair of elements of A. For example, if set A is 1, 2, then the relation R would be set of ordered elements. For example, A 1, 2, that is, it will make one edge. Or in case of multiple edges, it would be 1, 2 and 2, 1. A graph in which edges have a number associated with them is called a weighted graph or network, and the number is called the weight. For example, if you consider internet, then the routers would form this, and the distance between the routers would be the weight. For example, if you take a network of roads, then the distance would be the weight, or the time taken travel between two vertices would be the weight. assuming that the vehicle is a standard vehicle which we can find, and it travels at its maximum possible speed. So with certain conditions, you can define the time taken also as weight of a network of roads. A path of length L from vertex A to vertex B is defined as a sequence of L plus 1 vertices V1, V2 up to VL plus 1 such that V1 is equal to A, VL plus 1 is equal to V, and adjacent Vi, Vi plus 1 is true for all I between 1 and L. So this adjacent would be a piece of function which will return true for two vertices. A path from a vertex to itself is called a cycle, like we have shown in graph A and B. If a graph contains a cycle, it is called cyclic. This M is extra. Otherwise, it is acyclic. A cyclic graph is called a DAG, directed acyclic graph, from its acronym. So I'm not sure if you have used Git repositories or not yet in your programming career, but eventually you will learn to use Git when you will have a job, or you might already be using Git. The Git history or Git branches, they form a directed acyclic graph, where from the commit from main branch, so there are n number of commits on main branch, so that will make a linear line. Then other branches it take coming out from main and go merging to main further in the Git source directory or source tree would form a directed acyclic graph. So these are the jargon of graph. In the next video, we will start implementing graphs, how we can define a graph in terms of programming, and then we will try to represent in two ways. One is adjacency matrix and another is called adjacency list. Then we will see how do we find path between two nodes, how do we traverse using depth first search and breadth first search, and there will be common Warshall algorithms and so on we will study. So with this we come to the end of this video. I hope that you have found this video useful and informative. If so, please subscribe to the channel and like the video and share as much as you can. If you want to say something, please make use of the comment box. The reason for asking for subscription and liking and sharing the video is twofold. The objective is that the video should reach as many people as possible, and then that's how YouTube algorithms work, right? If you like the video, if you share it, then more views will come in and it will reach more people. The second objective of asking this is that it motivates me to make more such videos. And motivation is quite important because if it does not reach many people, then it is quite frustrating. It feels like the effort is going down. So with this, I will end this video. Thanks for watching. Happy programming.